And what I really need you to do is fill in all the vocabulary that was at the start of Chapter 4 so that you know the vocabulary and you know what vocabulary can be used with which kind of data collection method. So the idea of what you're doing in Chapter 4 is you are interested in a population. And interested in this population, you're interested in a parameter that is some kind of measure from the population. And probably that might be a mean, maybe the mean height of all of North Country students. So that is the entire group. And you can usually tell that entire group because they're using the word all. Like, I want to know the mean height of all North Country students. That's my population of interest. Now then, in order to get an estimate for that, from which we are going to make an inference, which is basically our best guess, we are going to collect a statistic. And that statistic would be X bar, and we would collect that from a representative sample that is going to be a subgroup of everybody. So I go out and I take a subgroup of North Country students, I get their average height of this subgroup, this sample, and that's my best guess at what the entire group's height is. So designing a statistical study, maybe from North Country, it might not be as difficult, but when you're designing a study from a very large, varied population, it's not very easy. So we have to make a plan, and this chapter is all about communicating that plan. So we first of all need to know who we're trying to study. That's the population. We want to specify what we want to measure about that population, and then we need to think about how we're going to gather our sample and how we would gather the data from once we've gotten that sample. Is it a survey, observations, experiment, or simulation? A special kind of sample that surveys everyone is called a census, which is kind of important right now in the year 2020 because they're doing a US Census right now. They're trying to get every single person in the entire United States. They're trying to get information about them, their age, their religion, everything, family sizes, how much money they make, just about everything. But that is incredibly hard. Why don't we always conduct a census? It's because, well, very hard to do, and it costs a lot. So this is why we do samples. Now, back to the height of North Country students. Now, if I was able to go out and take the height of every single North Country student, and then I would know the height of the average height of North Country students, there would be no need for me to do any inference, any testing, any kind of statistics, because I would know the fact of what the parameter is for the average height of North Country students. So if you are able to do a population, if you are able to get everyone in the population, then that means you actually know the answer, and there's no reason to do sampling, because sampling is what you do to make a guess at the population. Okay, so how do we use chance to select a sample? We want to be what's called being random. Now, in this case, in statistics, random does not mean haphazard. All good samples in statistics will involve randomness. It means having a systematic way where you're going to let chance decide who gets picked to be in the sample group. Okay, so here's an example. You would, using a table, for example, or a calculator, the first step would be to assign each individual numerical label. Like if I use my random number generator in class, I assign each student a number. Then, once everybody has a number, I use a random process to pick numbers. This table down below, it's a very popular thing to have happen in an AP test, because then every single AP student taking the test can be using the same random digit table to come up with their numbers. Now, when you're using a table like this, you want to use the least number of digits needed. To label individuals. Okay, so what do I mean? If you have 10 individuals, or you're trying to use a process that needs a 1 to 10, then use single digits and have 0 be person number 10. If you have 100 individuals, use double digits, but have person number 100 be 0, 0. And if you have 1 to 1,000, use triple digits with 1,000 being 000. Okay, so why don't I, and then in the AP test, they would have a digit on the side telling you what line to start on. So let's say I'm going to have you start on line 3. And let's say I am trying to pick individuals that I am going to label these individuals from, let's say I've got 80 individuals. So I would label 0, 1 to 80. Now I'm going to go to that line and let's see who we're going to pick. Okay, first line. So 0 to 8, I'm going 0, 1 to 80. First individual picked was 51. Next individual is 48, 67, 28, 75, 38, 60, 52. Individual 93 I'm going to ignore because that's not an individual that I want. So when I say I'm going to pick from 0, 1 to 80, I would also say that I will ignore 81 to 99 and 0, 0. So that's basically how you go through and you pick some numbers. Here, the next one's going to be 41, 80, 74, 98 is ignore, 01, 51, 33, 83 is another ignore. So basically you can just go through like that. Okay, then we could also use our calculator. So let's use I'm going to go to the calculator and show you how that would work. And I have the command here at the bottom of the page. It says we're going to use math prob rand int. So if I go to the calculator, okay, so I'm going to turn the things on. So I hit math, go to probability. The first one will just give you a list of random numbers. So you could just use that list as you would the table. So my first individual selected would be 12, 43, 3, 05, 39, so on. But I do like this one personally better, and this is one I use when I'm picking kids in class. Let's say I'm going to 80. So, and let's see, if you want to pick a certain number of individuals, you can hit N, but I'm just going to say paste. So first individual picked was 37. Next one is 38, 23, and you can just keep hitting enter and you can keep picking individuals. And you have to decide, like, if 40 comes up again, are you going to ignore it or are you going to use it? So that's random number, RNG for random number generator. I like that. Okay, so that's a way to be random. So here's some sampling methods that involved randomness. So it would involve that process that we just talked about, labeling the individuals, telling me how you're going to pick them. Okay, and from your vocab, you should have this in your vocab, but basically a simple random sample is when everyone has the same chance of being selected. And when you are doing this, you could think of it as like putting the names in a hat or using a random number generator after you've labeled everybody, things like that. You do have to decide if you're using a random number generator if you're going to ignore repeats or not ignore repeats. Okay, systematic sampling is when I think of you have your sampling frame. Sampling frame are the actual individuals you have available to you to talk to. And from that sampling frame, you're going to pick your sample. So your sampling frame is usually a list of the individuals available. Now you might have a sampling frame, you'll have a sampling frame for SRS too, and it might be a list. Again, that's usually like a numbered list of individuals. Now, in a systematic sampling, you pick a system. Like, are you going to go every nth person? Like every 10th on the list? Or 100th on the list? You have to come up with a system, but the important thing is you can't always start with the first person on the list, because then that means that that person would have a probability of 1 of being selected. You need to randomize. So here's where the randomness comes in. You need to randomize which person you start it with. So probably what I would do is say I was going every 10th person, then person number 1 to 10, if I was going every 10th person, then person number 1 to 10, I would use a random number generator to pick the start. So maybe if I'm starting on say number 6, then I would go 6, 16, 26, like that. So very important, you have to have some kind of random thing in the process. Stratified sampling and cluster sampling look really similar to each other, and sometimes people have trouble determining which is which. But what I think of with stratified sampling is you're going to group, and then you want to take a little from each group. So when you group, you have probably done your group by a characteristic. Like, for example, at North Country, maybe you think that freshmen, sophomores, juniors, and seniors, that they're different from each other. I'm grouping them by characteristic of age. Then maybe I would use a random number generator or a table, and I would use randomness to take a little bit from each group to make a little selection. So I might select 20 freshmen, 20 sophomores, 20 juniors, and 20 seniors, but I would have done that with a random process. And then that would give me a little bit of a taste of each of the strata. Okay, they are like layers. And they are based on a characteristic. Now, this is different from in a cluster sample where you, again, group, but this time you take all of 1, 2, or more, depending on how many you need, of the groups. And you use randomness to pick the whole group. So if I was doing this, let's say at North Country, we've got kids in classrooms, and let's just say that the classrooms have all the grades mixed into them. All the kids are mixed up, they're all in the classrooms. I feel like each group to group has a similar characteristic. Okay, because remember I said that all these classrooms have mixtures of kids, all different grades. Then I might say, okay, I've got 50 classrooms. I'll use a random number generator labeled 1 to 50. I'll select 5 numbers from 1 to 50, and then those 5 groups that have been selected, they'll become my sample. So when you group the people by similarities, similar characteristics, then you can take all of a group, and so one group can represent all the groups because you felt that the group to group was similar. Those were good sampling methods. Now, just to mention about some sampling methods that are really not good, and they have what's called bias. And bias is when you have a systematic error in the way you're doing something. And you can think of what direction is that bias going in? Is it making you feel like heights are taller? Is your bias going with heights smaller, shorter? If there's you always want to try to identify the direction of the bias, and if you can't identify it, you need to say why you couldn't identify it. So, for example, if I was interested in study habits of North Country students, and if the library was actually open, and I went down to the library and I asked the students in the library about how long they study on average in school, that would be what's called a convenience sample. And if I went to because it's something easy to do, going to the library and asking them about their studying, but I think that by going to the library and asking them about studying, I probably would have overestimated the true parameter value of study time. So when you go and see something is convenient, you need to ask yourself, what about the situation will over or underestimate the parameter. So basically, what about this statistic that you just got, this value of study time, does it overestimate because kids in the library tend to study more? That's going to overestimate that parameter that you are really trying to get for the population. So convenience sampling can be recognized because it was easy, but not a good random method of selecting people. Okay, then we have what's called a voluntary response sample, also known as a self-selected sample. And in a voluntary response sample this one's a terrible method of sampling. It's when you just say, you put it on the radio, please call in and tell us what you think about this situation. Or they put it in the newspaper, please write into the newspaper and tell us about this. Or please call American Idol and tell us who you're voting for Best Singer. Then what happens is the people who care or have a passion about it they respond, don't they? They're the ones who will pick up the phone and call. So we have to ask ourselves, why were they coming forward? And then that would be a bias. So we have to remember that we always have to identify the direction of the bias. So we have to decide what under or over prediction resulted. Over or under. Whoops, prediction. And this is slightly different. This gets confused a lot with what's called non-response bias. Non-response is when I asked, but you would not answer. You refuse to answer. So I think the difference here would be if the principal sent out an alert now and said, okay, all North Country parents, please phone in and give us your child's height. Only the people who care are going to call in about the student's height. Not sure if that would have over or under predicted. So I'd say, I'm not sure if parents who would call in that situation, what it would have done for a bias. So I'd need to say that. That was voluntary response. I just had an alert now. It said, please call in with your student's height. Now, if instead I sent a survey, a piece of paper to each household, and I said, okay, here's a survey with a self-addressed stamp with a envelope, and it's got the stamp on it and everything. And I say, okay, please take this piece of paper, fill out your student's height, and mail it back to North Country. If they don't mail it back, that's non-response. That means that there's some reason why those people are refusing to tell me the kid's height, and I'm not sure why. So I don't know what the bias would be, but I'd have to say that. I don't know what the bias would be in that situation. So when you're designing your good sampling method, make sure you think about, is the part representative of the whole? So think about your sampling frame. Who is actually available? Is that sampling frame is that sampling frame representative of the population? For example, a lot of drug studies don't involve minorities. So if they're trying to represent, with the vaccine trials, if they're trying to represent all of humanity and how everybody will respond, whether you're, ethnically, from Asia or from Africa or from Europe or whatever your mix of ethnicity is. Probably the people they're testing this on are white males. And so pretty much the females and any ethnic group is being left out of the whole. So you have to ask yourself, did your sampling frame really represent everything that you were trying to estimate this for? Then when you're doing that process, make sure that all your subjects had a chance to be selected, and that you kept your own personal biases out, and that would reduce that underestimating and your overestimating. And that's being randomized. And then size, sample size does matter, but not really the size of the population. So if you think about making soup, like if you have this whole pot of soup, and if you think of like you're randomizing as basically you're mixing, then if you've got this soup in here, like 1 spoonful might be enough of a sample size to test it and get a good idea of the soup. But then maybe there'd be some other food where you'd need something larger sample size. But so even a small sample size can be representative of the population if it makes sense for the situation. Okay, so I'm going to do a different video for this one where I just walk through doing some writing out all the words that make the process.